All right, folks, welcome back. And we are going to finish up this chapter on chemical formulas by talking about hydrated compounds. We have a lab coming up in class where we work with hydrated compounds. So, hydrated compounds are solids, usually ionic in nature, that contain water molecules in their crystal lattice. So, probably the most commonly used example is this compound here. Let's name it really quickly. Cu is copper, and copper is one of those that I need Roman numerals for. Don't you agree? It's a D block element, and it's not zinc, cadmium, or silver, so we're going to leave space for Roman numerals there. And SO4, that's a polyatomic ion. We'll go ahead and look that up. It's been a while since we've done that. Here's SO4. It's called sulfate. So this is copper something, sulfate. Let's fill in the Roman numeral here. Sulfate, if you recall, was 2 negative. I'll just show it to you again. See, it's 2 negative there, kiddos. And we have 1 copper stuck to it. So what's its mystery charge? Well, if sulfate's 2 negative and the charge has to add up to 0, doesn't copper have to be 2 positive? So we're going to put the Roman numeral 2 in there. So we call it copper 2 sulfate. Now then, what's going on over here with these waters, with these 5H2Os right here? Well, those are called waters of hydration. And this dot right there is not a multiplied by sign. It means that those 5 waters stick within the crystalline lattice to the copper and sulfate ions. In fact, the ratio would be for every 1 copper sulfate unit, there are 5 water molecules stuck to it. So the way we would name that is we would say the normal name, copper 2 sulfate, and then we'd use the Greek prefix for 5, which is penta, and we'd end with hydrate. So the name of that compound is copper 2 sulfate pentahydrate. Now make sure you folks know your Greek prefixes for this. Remember, we learned those with covalent compounds. So here are just a few more examples. Ammonium oxalate, and there's only 1 water there, so we call it monohydrate. And then we have calcium chloride with 2 waters, so that's a dihydrate. Sodium acetate with 3 waters, so that's a trihydrate. This would be an iron Roman numeral 3 phosphate with 4 waters, so that's a tetrahydrate. And of course the one we just did, copper 2 sulfate pentahydrate, and then so on. Okay, so let's try one of these on the next page. So if we can find the ratio of water molecules to each formula unit of the ionic compound. It's not too hard. I mean, you've got the hard part of this chapter finished with empirical and molecular formulas. This really is just more of the same stuff. So, if we have an ionic compound that weighs 0.737 grams without water, we call that anhydrous. That means without water. And when we evaporate off the water, we find that there were 0.763 grams of water stuck in that crystal. So we want to find the formula. Now the formula will be MgSO3 dot some number of water molecules. And to find that, it's a mole ratio. So I think you guys know where I'm headed with this. If we want a mole ratio, we need to go from grams to moles, don't we? So we're going to go from grams of water to moles of water. And 1 mole of water is 18.02 grams. That's the weight of 2 hydrogens and an oxygen. And we're going to go from grams of MgSO3 to moles of MgSO3. So we have to find the weight of this. So MgSO3, each magnesium is, let's take a look, magnesium 24.30 for my magnesium. 24.30. There's a sulfur, one of those. If you remember, those are 32.06. and there's 3 oxygens, which are 16.00 apiece. So let's figure out the weight of this compound. Be 24.30 plus 32.06 plus 3 times 16 is 48, and we get 104.36 grams per mole. All right, so that will give us moles of MgSO3, 2 moles of H2O. So 0.737 divided by 104.36, that gives me 0.00706 moles of MgSO3, and 0.763 divided by 18.02 gives me 0.0423 moles of water. Now obviously those are not whole number ratios, so we need to divide by the lowest number of moles, 0.00706. So we have 1 and, let's see, 0.0423 divided by 0.00706 is 6. So that means the formula for the hydrate is MgSO3, we have one of those, dot 6 waters of hydration, right there. So the name of that compound would be magnesium sulfite hexahydrate. Magnesium sulfite hexahydrate. Okay? All right, let's try another one. So we have 2.50 grams of a hydrated copper sulfate, XH2O. It's placed in a crucible and heated. After heating, we only have 1.59 grams of the anhydrous remaining. What is the formula for the hydrate? And then I want you to name it. So let's take a look. Let's figure this out. We have 1.59 grams of CuSO4, that's the anhydrous. And we have to figure out grams of water, don't we? Well, let's see. If the compound weighed 2.5 grams with water and 1.59 grams without water, the difference would be 0.91 grams of water. So now we have our grams of anhydrous compound and our grams of water. So we need to convert those to moles. So I'll go from grams to moles of CuSO4 and grams to moles of H2O. Put a 1 by mole, and water is 18.02 grams per mole. That will give us moles of water. And copper 2 sulfate. Let's figure out the weight of this. We have a copper, and that's 63.55 grams per mole. We have a sulfur, 32.06 grams per mole. And we had 4 oxygens. Each one weighs 16. So that's another 64 grams per mole. So I get 159.61 grams per mole of copper sulfate. And when I do the math there, I'd have moles of CuSO4. So let's see what I get. 1.59 divided by 159.61 is 0.00996 moles of copper 2 sulfate. 0.91 divided by 18.02 is 0.0505 moles of water. So we'll divide by the lowest number of moles. Looks like that's 0.00996. And let's see what we get. That's a 1. 0.0505 divided by 0.00996. That's a 5. So that means the formula for my hydrated compound would be CuSO4.5 H2Os. So the name of that would be copper 2 sulfate pentahydrate. Wasn't that the example that we started this particular video off with? I believe it was. Okay? All right, let's do one more and we'll call it a video. Does that sound good to you? Alrighty. This one, we have percent by weight again. 48.8 grams or percent of magnesium sulfate and 51.2% water. We'll assume we have a 100 gram sample. So we would have 48.8 grams of MgSO4 and 51.2 grams of water. Okay, you finish this problem off. Come back to the video. We'll see how you did. See you in a sec. All right, welcome back. We're going to have to go from grams of MgSO4 to moles of MgSO4 and grams of water to moles of water. 18.02 for water. Then we have to figure out the weight of MgSO4. So if you remember, magnesium was 24, let's take a look. We just looked at that a minute ago, 24.30. And we have a sulfur, 32.06. This time we have 4 oxygens. So 4 times 16 is 64.00. So I get this time 120.36 grams per mole. So let's figure out our moles of MgSO4 and our moles of water. So for MgSO4, 48.8 divided by 120.36 gives me 0.405 moles, and 51.2 divided by 18.02 gives me 2.84 moles. So let's divide, we'll do this work down here. Let's divide these by the lowest number of moles, 0.405 divided by 0.405. That's 1 for my MgSO4. And 2.84 divided by 0.405. Let's see what that is. 2.84 divided by 0.405. That is 7 for my waters. So my empirical formula would be MgSO4 dot 7H2O. Its name, of course, let's see, Mg is magnesium. SO4 is a polyatomic ion called sulfate. And just by the way, magnesium does not need Roman numerals. And then the Greek prefix for 7 is hepta. And then we end it with hydrate. So the formula, MgSO4 dot 7H2O, excuse me, and the name magnesium sulfate, heptahydrate. All right, there you go. Hopefully you're pretty good at finding empirical and molecular formulas as well as finding the formulas for hydrated compounds. Thanks for being with me. Talk to you soon. Bye-bye.